Hello everyone, welcome to my YouTube channel. Today let us learn about the subject Mathematical Foundation for Computing Probability and Statistics. The topic we are going to discuss today is Introduction to Sampling Distribution. So the contents we discuss today are: what is the sampling distribution, how sampling distribution works, special considerations, types of sampling distributions, what is a mean, determining a sampling distribution, plotting sampling distribution. So let us learn about what is sampling distribution. The sampling distribution of a statistic is the distribution of all possible values taken by the statistic when all possible samples of a fixed size n are taken from the population. It is a theoretical idea, we do not actually build it. The sampling distribution of a statistic is the probability distribution of that statistic. A sampling distribution is a probability distribution of a statistic that is obtained through a repeated sampling of a specific population. It describes a range of possible outcomes for a statistic, such as the mean or mode of some variable of a population. The majority of data analyzed by researchers are actually samples, not populations. So let us learn about how sampling distribution work. Data allows statisticians, researchers, marketers, analysts, and academics to make important conclusions about specific topics and information. It can help businesses make decisions about their future and boost their performance, or it can help governments plan for services needed by a group of people. A lot of data drawn and used are actually samples rather than populations. A sample is a subset of a population. Put simply, a sample is a smaller part of a larger group. As such, this smaller portion is meant to be representative of the population as a whole. Sampling distributions or the distribution of data are statistically metrics that determine whether an event or certain outcome will take place. This distribution depends on a few different factors, including the sample size, the sample process involved, and the population as a whole. There are few steps involved with sampling distribution. These include choosing a random sample from the overall population, determine a certain statistic from the group, which could be the standard deviation among all the mean, establishing a frequency distribution of each sample, mapping out the distribution on the graph. Let us learn about special considerations. The number of observations in a population, the number of observations in a sample, and the procedure used to draw the sample sets determine the variability of the sampling distribution. The standard deviation of a sampling distribution is called as the standard error, while the mean of a sampling distribution is equal to the mean of the population. The standard error depends on the standard deviation of the population, the size of the population, and the size of the sample. Knowing how spread apart the mean of each of the sample sets are from each other and from the population mean will give an indication of how close the sample mean is the population mean. The standard error of the sampling distribution decreases as the population increases. So, let us learn about types of sampling distribution. There are three types of sampling distribution. First is sampling distribution of the mean. This method shows a normal distribution where the middle is the mean of the sampling represents the mean of the overall population. In order to get this point, the researcher must figure out the mean of each sample group and map out the individual data. The second one is sampling distribution of proportion. This method involves choosing a sample set from the overall population to get the proportion of the sample. The mean of the proportions ends up becoming the proportions of the larger group. The next one is t-distribution. This type of sampling distribution is common in cases of small sample sizes. It may also be used when there is very little information about the entire population. T-distributions are used to make used to make estimations about the mean and other statistical points. So let us learn about what is a mean. A mean is a metric used in statistics and research. It is the average for at least two numbers. The mean may be determined by adding up all the numbers and dividing the result by the number of numbers in that set. This is known as the arithmetic mean. You can determine the geometric mean by multiplying the values of the data set and taking the root of the sum equal to the number of values within the data set. So let us learn about determining a sampling distribution. Let's say a medical researcher wants to compare the average weight of all babies born in the North America from 1995 to 2005 to those from South America within same time period. Since they cannot draw the data from for the entire population within the reasonable amount of time, they would only use 100 babies in each continent to make the conclusion. The data used in the sample and the average weight calculated in the sample is the mean. Now, suppose they take repeated random samples from the general population and compute the sample mean for each sample group instead. So, for North America, they pull data for 100 newborn weights recorded in the US, Canada, and Mexico as follows: 400 samples from selected hospitals in the US, 570 samples from Canada, 3 150 records from Mexico. The researcher ends up with a total of 1,200 weights of newborn babies grouped in 12 sets. They also collect sample data of 100 birth weights from each of the 12 countries in the South America. The average weight computed for each sample set is the sampling distribution of the mean. Not just the mean can be calculated from the sample, other statistics such as the standard deviation, variance, proportion, and range can be calculated from sample data. The standard deviation and the variance measure the variability of the sampling distribution. So let us learn about plotting sampling distributions. A population or one sample set of numbers will have a normal distribution. However, because the sampling distribution includes multiple sets of observations, it will not necessarily have a bell curve shape. Following our example, the population average rate of babies in North America and the South America has a normal distribution because some babies will be underweight below the mean or overweight above the mean, with most babies falling in between around the mean. If the average weight of the newborns in North America is 7 pounds, the sample mean weight in each of the 12 sets of sample observations recorded for North America will be close to 7 pounds as well. But if you graph each of the averages calculated in each of the 1,200 samples groups, the resulting shape may result in a uniform distribution, but it is difficult to predict with certainty what the actual shape will turn out to be. The more samples the researchers use from the population of over a million weight figures, the more the graph will start forming a normal distribution. So, thank you everyone. Please like, share, and subscribe my channel. Thank you.